All right, so we're finally to the point of knowing what the big deal is with logarithms. Why do we have them? What purpose do they have? Now that we know how to switch between the two forms, we know how to combine, we know how to expand, all of the things we've learned about logarithms now come into play at this point. If you ever come across a problem, and you will in the next year or two of math, you come across a problem where you can't use base numbers, here's the real reason why logarithms are so awesome. So you may come to a problem where you have your variable in the exponent and you can't change both sides to be equal base numbers. In the past, when you have had a problem like this, you change both the base numbers, set the exponents equal, and figure out what x is. These situations, you can't do that. So whenever you come across something like this where you can't use base numbers, what you're going to do is rewrite it with the word log in front of both sides. Okay, what this does is it allows us to solve this problem because, remember, when we're logging both sides, there's really a little 10 here. And here's where our calculators are finally going to come into play when using logarithms. So you'll want to get your calculators out as well. Looking at this problem, we learned yesterday that this exponent can be moved, which is really nice because the x, which is what we're trying to solve for, is now no longer an exponent. It's down where it normally is when we solve for x. So we have x log 10 of 3 equals log 10 of 15. In order to get x alone, when there's no symbol here, remember we're really multiplying. In order to get x alone, we're really only going to have to divide by log 3. Log 3. So in your calculators, all you're going to do is put in log 15, and there is a button that says log. Okay, so you hit log 15, and it's going to give you a parenthesis on most calculators. Make sure you close that parenthesis before you hit the divide button, log 3. And you don't need to close the last one, but you can. You'll get the same answer regardless. Okay, so everyone get their calculators out, punch this in. I want all of you to get the same answer. Here's what everybody should be able to get, 2.46. So if you take 3 to the 2.46 power, you're going to get something very close to 15. That's what we were finding up here, was what exponent would give us a number 15. And obviously it's going to only be very close to 15 because we didn't write down every single number in this answer. We rounded it off at 2.46. All right, so next problem. 5 to the x plus 2 equals 37. Again, we can't change both sides to the same base numbers. In fact, 37 is a base number and 5 is a base number, and they're not equal. So we're going to log both sides. Now the exponent, just like we learned yesterday, gets to move. And when you have something with a plus or a minus in it, like we do on this case, you do want to put parentheses around it. Okay, and just like before, in order to get x alone a little bit more, we're going to divide by this log over here. So now we're just left with x plus 2 equals, and get out our calculators again, figure out what this is. Now we're in the middle of a problem, so you don't want to round the number off so short this time. We're going to want to write down at least 5 or 6 numbers after the decimal because we're halfway through a problem. All right, so when I divide those, 2.24359. Then the only other thing is to subtract 2. So we get 0.24. And you can shorten up your answer at the very end. But you always, it's a good rule of thumb, if you're halfway through a problem or quarter of the way through a problem, you always want to write down a bunch of numbers after the decimal so that you get the same answer that everyone else is getting. If you round it off too early, your answer ends up being very different from your neighbors and the book. Okay, let's try another one. All right, so this one says 8 raised to the x squared is equal to 46. All right, so again, we need to log both sides. We get to move the exponent. So now it's x squared in front. Again, we're solving for x, so just like we did on the first two problems, we have to do the exact same thing and move this log that's next to it. So we've got log 8. That leaves x squared alone. Divide those two logs, and we get 1.841187. Again, wanting to write down a lot of numbers after the decimal because we're not done with the problem yet. Last step to get rid of this squared, to square root both. And like I told you before with your calculators, don't ever press clear. This is the entire number. It's not rounded off anywhere. It has the entire number stored in here. So you just want to square root this answer. So you're going to hit your square root, and then right above your negative sign on the TI-30X, which is what most of you have, you see ANS, which is for answer. That pulls up the previous answer, and you should get 1.36 for an answer. If you don't have a TI-30X, ask a neighbor to help you find where your ANS for answer, previous answer is, and it'll do that for you. All right, so just to recap this slide before the last page, anytime you don't have two sides where you can change on base numbers and you have your variable in the exponent, you want to log both sides and then pull that exponent down front and get x by itself. All right, last thing we need to look at is what's called the change of base formula. Anytime you have a log and they give you a base number, which is obviously other than 10 because they're going to put a different number in there, you can find the answer to this simply by taking log, oh that's really hard to read, log of b over log of a. Let me write that in blue. All right, so for instance, if they want you to figure out the answer to log base 3 of 8, in your calculator, all you have to do is take log 8 divided by log 3. And I do want you to show that work so that I know that you're using the change of base formula. So in your calculators, we've got log 8 divided by log 3. And we get 1.89. Write it in two colors just so you can see. All right, pretty sure you all know how to use your calculators by now, so we're just going to set these ones up. If you would see this one, we would get log 10 over log 2. And that's what you would put in your calculator. And this would be log 18 over log 9. The order is easiest for me to remember by looking at the fact that when you're looking here, the 18 is a little bit higher than the 9, so it's like 18 over 9, and that's how I always remember the order. So since the 18 is above, the 18 goes above when you're writing your fraction, and the 9 looks like it's down underneath a little bit, so the 9 goes on the bottom. So that's what we're doing in the homework today. Assignment sheets you guys already have. So get working on the homework. Let me know if you have questions.